Dilations. Dilations enlarge or shrink a shape by a given scale factor. A scale factor is just a number that indicates how much a shape is increasing or decreasing in size. Scale factors with an absolute value greater than 1 enlarge that distance, and those with an absolute value of less than 1 reduce the distance. Negative scale factors are a little bit special because they dilate the shape and they also rotate it 180 degrees. When dilating shapes, the distance from the center of dilation to a vertex or any other point on the original shape is multiplied by the scale factor to get the location of the corresponding point on the image. That's a whole lot of stuff. Let's look at an example. Let's look at an example where the center of dilation is right in the center of the shape. And we're going to use a scale factor of 2. And the center of dilation is over 4 and up 3, so 4, 3. When we're doing dilation, everything starts from the center of dilation. We look at that center of dilation and we say, how far do we have to go from that center of dilation to get to the first vertex? And we're going to work with A as the first vertex. So we're going left 2 and down 1. So that vector is left 2, so that's negative 2, and down 1, which is negative 1. We have a scale factor of 2, which means that vector is going to get twice as big. So we're going to multiply each of those components by 2, which gives us negative 4 and negative 2. So that's the vector that gets us to the new location of A, or as we call it, A prime. So we're going negative 4 and then negative 2. That is our A prime. We can do the same thing with B. In this case, B is left 2, so that's negative 2, and up 1, so that's a positive 1. So that's negative 2, 1. Multiplying each of those by 2 gives us negative 4, positive 2 this time. Starting from the center of dilation again, we're going negative 4 and up 2. And that's the location of B prime. Same process for C. Starting from the center of dilation, we go right 2 and up 1. Multiplying that times 2, we get 4, 2. So we go over 4 and up 2. There is our C prime. And finally for D, we can see that we go to the right 2 and then down 1. So that's a positive 2 and a negative 1. Multiplying those times 2, we have 4, negative 2. So that means we go over 4 and down 2. And that's our location of D prime. Now we can connect up those vertices, and that gives us our dilated shape. You can see that the shape has basically grown in place. And a key fact to identify here now is that when you connect the center of dilation to each of the new vertices, you'll see that those lines pass through the original vertices as well. That's going to hold true regardless of where the center of dilation is. Now let's look at a different example. This time the center of dilation is going to be at 8, 6. So that's 8, 6, over 8, up 6. And we're going to stick with the same scale factor of 2. This time we're going to find the vector that leads from the center of dilation to each of the vertices. To get from the center of dilation to A, we go left 6, which is negative 6, and down 4, which is negative 4. So negative 6, negative 4. Vertex B is negative 6, negative 2. Vertex C is negative 2, negative 2. And vertex D, negative 2, negative 4. So those are the vectors from the center of dilation to each of the current vertices. Now what we need to do is to look at our scale factor and multiply each of those vectors to get the vector that will get us to each of the prime, or each of the vertices on the image. So multiplying each of those by 2, we have a new vector that says negative 12 and negative 8. So to find A prime, we're going from 8 and we're going negative 12, which takes us all the way over to negative 4. And then we're going down 8, so we're currently at 6. That would take us down here to negative 2. So there is our A prime. Doing the same for vertex B. Multiplying each of those, we've got negative 12, negative 4. Going to negative 12, and this time just down negative 4. Vertex C, multiplying its vector by 2. Going negative 4, negative 4, negative 4, negative 4. That gives us C prime. And D prime we'll get by multiplying the D vector times 2 is negative 4, negative 8. Negative 4, negative 8. And we join those points up to get the vertices of our new image. So you can see two things have happened. The green box, which is the image after the dilation, is twice as big as the original, and it's also been translated, so it's been shifted, it's been moved. Because the center of dilation is not happening right at the center of the shape, that causes it to move when you do the dilation. Now remember what we showed last time, where if we take the center of dilation and draw a line directly to each of the new vertices, you can see that each of those lines, each of those vectors, passes directly through the original vertex as well as the new vertex. So the vector that passes through D ends up at D prime. To get to C prime, we pass through C. To get to A prime, we pass through A. And to get to B prime, we pass through B. That's how you perform a dilation using a scale factor and the center of dilation. So far, we've only been working with positive whole numbers for the scale factor. Specifically, we've been using a scale factor of 2, but the process is the same regardless of whether you're using a positive whole number, a fraction, or a negative value for the scale factor. Remember, a scale factor greater than 1 means the image will be larger than the original shape. A scale factor that is a fraction means the image will be smaller than the original shape, and a negative scale factor means the image also undergoes a 190-degree rotation as well as changing in size.